equations, we're going to graph on the same set of axes. And we're going to get these two lines. And usually what happens when you draw two lines, eventually they cross. And what we're looking for is to find the place where the two lines cross, the intersection point of the two lines. That point is called the solution of the system of equations. So let's go ahead and do this. Let's call this what? Equation number 1. Let's call this equation number 2. Okay, so let's look at equation number 1. Number 1 says x plus y equals 2. So if I want to solve the graph that, I want to get the y alone. I want to put this in the y equals mx plus b form. So I'm going to subtract x from both sides, and that'll give me y equals negative x plus 2, which means for this particular example, the slope, the m, is the number, the coefficient of the x. Remember, it doesn't include the x. It's just a negative. Obviously, it's a negative 1. The 1 is understood. Remember, usually when we're using a slope to graph, we want to write it as a fraction so we know the rise over the run. So therefore, this would be negative 1 over 1. Is it wrong to write it 2 minus x? It's not wrong to write 2 minus x, but you have to remember when you're looking at it that the number in front of the x is the slope, and the number that stands alone, the line that doesn't have any number, is the b, the y-intercept. So the b is 2. It doesn't matter as long as you remember it. I usually put it in what we call the mx plus b. We put the x term first and the number second to remind us that the slope would be the negative 1 and the y-intercept is 2. And if we go to graph this line, we know when we want to graph it, we start at the y-intercept, which is 2. So we go up here at 2. And then we use our slope of negative 1. Remember, which means negative 1 over 1, which means you go down 1, 1 to the right. You could do this a second time, down 1, 1 to the right. You could also optionally put the negative in the bottom, and then you could have gone up 1 and 1 to the left. You don't have to do it so many times. You have to do it, but you want to draw your line. Here is line number 1. Okay, now we want to look at our second line. Our y equals 2x minus 1. This is already in the y equals mx form. So I don't have to do any work on it. I just have to state my slope, which is the number in front of the x, which is 2. Again, we write that as 2 over 1 because we'd like it to be a fraction. And the y-intercept, the b, is negative 1. So for this second line, for line number 2, we're going to start at 1 down right here. And then we're going to go up 2 over 1, up 2 over 1, or conversely, we could have gone down 2, but then we'd have to have gone 1 to the left. And we get a line that looks like this. Here's line number 2. So here we've drawn our system of equations, both lines on the same graph. The solution to the system of equations is the point where the two lines are intersecting. Now I have to figure out what that point is. Now, if I look at it, it looks like I'm going one to the right and one up to get to this point. In other words, looks like the point 1, comma 1. The solution is, if I asked you, what is the solution of the equation? You can write it in two ways. You could write the solution is 1, 1, or you can say it separately, x equals 1, y equals 1. Remember, the first number, it's an order pair, so the first number is always the x, the second number is always the 1. If you notice, these numbers really work, because when I replace the x with 1 and the y with 1, I'll get 1 plus 1, which is 2. That checks. And when I replace the over here with the x and the y with 1, this will give me 1 equals 2 times 1 minus 1, and that's 2 minus 1, which is 1. So both of the answer has to work in both equations to be a solution. And this is what's called solving a system of equations. And what we're doing here, you have to understand, is we're finding the point where the two lines that we get from those linear equations intersect, which means we're finding the point whose x and y coordinates fit into both equations. Now, this is what we're doing in this chapter. We're solving the system of equations. There's something a little bit that causes a little bit of difficulty. Number one, if you notice, I'm trying to do this on something that's really not a graph board. I'm not getting always, and I was lucky, I picked the right answer, but sometimes my answers might be off. It's simply because my graphing is not so perfect. Number two, sometimes even with perfect graphing, my answer could have come out to be something like 1 3/4. And I would not be able to read that very carefully, even if I did it on very good graph paper. So the idea behind it is great. The method is understandable, but it's not always the most efficient method, and it's not always the most accurate method. We can do everything totally right, but it's sometimes not so easy to read the correct answer. So the question is, what other way could we go about doing or solving this system of equations? And we're going to see there are other methods that we can use to solve a system of equations, that are much quicker and give us a very accurate answer. We don't have to start trying to figure out, are we doing this right or not? Before I go on to discussing those methods, I just want to show you the different types of scenarios that might come up when we have something like this. This is the most common type of situation. We get two lines, they cross, we find the point where they cross. There's one answer, even though there are two numbers that consist of a single point. There's one x and one y, a single answer. When we have something like that, we have what's called a consistent system of equations. A single answer, a single point where the two lines intersect. Okay, I'm leaving this system of equations up here. And because I'm going to do it a different way in a few minutes. And just reminding myself the answer that came out was 1, 1. Okay, let's just keep that as a guide for us. Just remind ourselves. Before I go into this other method that we could use, I want to show you other things that could possibly have happened when you have a system of equations. Let's say one thing might have been that when I went to draw my lines, here would be my first line, and here would be my second line. And suppose when I drew those two lines, the lines turned out to be what we call parallel lines. They never meet. If the lines are parallel, what would be the solution to this system of equations? And obviously, there can't be any solutions. There's no solution because there's no point where the two lines intersect. They're parallel, which means no matter how long I extend them, they're going to be totally separate. They're never going to cross. No solution. Sometimes we just use the word no solution. Sometimes we use this 0 with a line through it to indicate no solutions. When does this happen? When the lines are parallel. Would we be able to tell if the lines are parallel ahead of time? Anybody have any suggestions? How would you know if the lines were parallel ahead of time?
Do they have the same slope?
Right, thank you, Adina. And who else said that? Reggie, was that you?
Yeah.
Yes, so we had two people who came up with the exact same answer, one on the chat, one on in person. Yes, and we would be able to tell if we put the lines in the y equals mx plus b form, we'd know right off the bat by looking at the number in front of the x. If those numbers are the same, then the two lines would be parallel, and we would know right away there would be no solution. We call this an inconsistent system of equations, where the two lines never meet and there's no solution. So that's the second type of situation we could encounter with a system of equations. There is another thing that might happen. This is the third type of situation. You draw your first line, we get your line 1, and then you go and you draw your second line. And the second line comes right on top of the first line. It's really not a different line. It's the exact same line. When you looked at the original equations, you didn't notice this, but if you would put them both in the y equals mx plus b form, not only would they have the same slope, they would have the same f, they would also have the same b. Here, they wouldn't, when it's inconsistent, the b values are different. But here, not only is the m the same, the b is the same as well. The slope and the y-intercept are the same. And the two lines are really not two lines, it's just a single line. And in that case, if you're looking for points that are both lines, every single point that's on one line will be on the other line. In other words, there'll be an infinite number of solutions, millions and millions and millions of solutions. Any point on one of the lines will be a point on the other line. And this type of system is called a dependent system of equations. Because they're really not two separate equations, but one equation actually, they're not independent of each other. They really are the same equation. So those are the three situations that could arise when we have a system of equations. The most likely one is the first one, that we'll get a consistent system of equations. But there is also the possibility that you'll get a system where there's no solution, or one that has an infinite number of solutions. Okay. And we actually have ways of telling if this is going to happen even before we go ahead and do the work. What I'd like to do now is to go back to this original equation that we did graphically and show you another method of doing it, and something called an algebraic method. An algebraic method that will allow us to find the solution of the system of equations without actually graphing it. And not only is it generally a quicker way of doing it, it's a more accurate way. Even if my answer turns out to be in fractions, I'm going to end up with okay, so I'm going to demonstrate it using our original examples. Our first equation was the x plus y equals 2, and our second equation was y equals 2x minus 1. And the method I'm going to be using is something called the method of substitution. You know what substitution means. It means using one thing in place of something that's equal to it. If you have two things that are the same or equivalent, or really they are the exact same thing, then you could use one in place of the other. We do this with people's names all the time. Let's say we have somebody whose name is really Theodore, but a lot of people call him Ted. So we will call him Ted, even though his name is really Theodore. We're substituting the name Ted for the name Theodore. We're going to do a similar thing with our equations. This method usually is best used when in one of the equations, y is explicitly written in terms of the x, or the x is written in terms of the y. Notice here the x's and the y's are mixed up together. This is what we call a standard format, where we have an x, a y, an equal, and a number. But in this equation, in equation number 2, it says y equals 2x minus 1. We're telling you what the y is in terms to what it is in terms of x. Now, that means in this problem, y can have two names. Y can be just called y, or y could also be called 2x minus 1. When two things are equal, it means they're identical and they can be used interchangeably. So what I'm going to do is I'm going to take my first equation, and where I have the y, I'm going to replace the y with its equivalent, what it's equal to, the 2x minus 1. I have substituted for y in my first equation, 2x minus 1, because my second equation is telling me that y is equal to 2x minus 1 and can be used in place of it. Now, the advantage of doing that is that now I only have an equation that has only x's in it. It doesn't have two variables, so that I can solve it. Remember, there's this, if I put parentheses here, so I go 1 in front of the parentheses, and when I remove the parentheses, I get x plus 2x minus inside here by 1. Combining the like terms x and 2x gives me 3x minus 1 equals 2. And adding 1 to both sides will give me 3x equaling 3. And then finishing this equation, I get x equal to 1, because 3 divided by 3 is 1. I found out that the x value in this system of equations should be equal to 1. To find out what the y is, I can use either one of the equations. I'm going to use the second one because it tells me what y is. And I'm going to replace the x in that equation by 1, because now I know that the x is equal to 1. So I get y equals 2 times 1 minus 1, which is 2 minus 1, or 1. And again, the solution to this system of equations is x is 1 and y is 1, which is exactly what we had gotten graphically. The advantage to this was that it was quicker, it was less work, and it was very accurate. We knew that we were not running into any difficulties with fractions or decimals. This was the exact right answer. You think you're ready to try one on your own? Okay, let's do one. And I'm going to give you a problem to try while I take attendance. I'm going to give one. And again, I'd like you to use the substitution method. So suppose I gave you this system of equations. 3x minus y equals -1, and x equals 2y minus 7. Notice in this equation, it doesn't say y equals, it says x equals. So I'm going to replace the x in this equation with the 2y minus 7. Okay, see if you can do that while I take attendance. Okay, if you hear your name called, please answer or send me a text. Maury? Maury here? Hi, good afternoon. Chelsea? Chelsea? Hi, good afternoon. Ariana?
Here.
Hi. Adina, I know you're here because I saw you answered my questions. Lachey, I think you answered a question also. Is Lachey here? Yes, I see
Yeah, I'm
you.
here.
Hi, how are you? Kava? Kava? Kava Collingwood? All right, seeing him. Terrence? Terrence? Hi. Karide? Karide,
Here.
Karide here?
Here.
Oh, okay, hi. Kizia? Kizia here? Okay, I see you're here, okay. Is Kizia here? Yeah, hi. Faith? Faith Diggs? Ethan? Ethan? Isabella?
I'm here.
Hi. Serenity? Serenity? Reggie, I know you're here because I saw you. Zamia?
Here.
Brandon?
Here.
Hi. Michaela?
Here.
Seraphine? Sarah,
Here.
hi. Marissa?
Here.
Hi. Renee?
Here.
Hi. Sky? Okay, got you. Jaden? Jaden Roberts? Kennedy? Kennedy here? Hi, is Kennedy here? Okay, good. Felicia? Felicia? Good. Natalia?
Here.
Good. Got you. Michael?
Here.
Good. Cassidy?
Here.
Hi. Megan? See you there. Yeah, I got you. Kalia Watson. Lauren, I see you're there, Lauren.
Here.
Hi. And Kayla Zachary. I think I saw you before, Kayla. Okay, if you come on, and I've already taken attendance, you can always send me a message on the chat. Okay, I think we should try and do this together now. All right. In this particular example, I see, I guess, some people are sending me answers. Let's see if these are the, in this particular example, it says that 3x minus y equals -1, and x is equal to 2y minus 7. In other words, another name for x is 2y minus 7, which means in my first equation, in place of that x, it says 3x, in place of the x, I can put the 2y minus 7. Another name for x is 2y minus 7. I can use them interchangeably. Notice I put a parenthesis around it because I want to make sure that I use the whole 2y minus 7. It's more than one term, so I have to put a parenthesis. I then do minus y equals -1. So all I've done is replace this x over here, substituted for it 2y minus 7. And now this is a type of equation we learned to do right at the beginning of the term. I'm going to remove the parentheses, so that'll give me 6y minus 21, because I have to use a distributive property, minus y equals -1. I combine my like terms of 6y and -y, which gives me 5y, minus 21 equals -1. So I'm going to add 21 to both sides to get the y's alone. So this will give me 5y. Be careful with your signs, -1 plus 21, this became positive because I'm bringing it to the other side, gives me a positive 20. And when I divide by 5, it gives me that y equals 4. To find out what x is, I can go to this equation over here. X equals, now I know the y is 4, so I'm going to do 2 times 4 minus 7, which will give me 8 minus 7, which is equal to 1. In other words, the solution to this system of equation is 1, not 8, I'm sorry, 1, 4. Remember, when you're writing the order plate error, it's always the x that comes first and the y that comes second. So this is how we could have solved this system of equations. We didn't have to graph anything. As a matter of fact, it would have been relatively difficult to graph. We would have ended up with fractions. Graphing this would have been difficult, but this method of substitution was very quick. Just be careful. Any questions about how I got these answers? Okay. There is another method that is also an algebraic. This is called an algebraic method. It doesn't involve any graphing. It's just a method in which we use equations to solve the problem. Okay, so what we're going to do now is we're going to look at another algebraic method, and we'll discuss when it makes more sense to use one method or the other. Really, all these 3 methods that I'm going to be discussing today could be used interchangeably, but one method is usually more efficient or easier to use than the other. So we want to go with the easiest method unless we're told specifically we have to use a specific method that they're giving us. Okay, so let's go on to this other method that's called the method of elimination. So let's say I gave you this system of equations. The first equation is x minus y equals 4 and the second equation is 2x plus y equals 8. Again, I have a system. Again, I have a system of equations. And I want to solve the system of equations. And again, I don't want to use graphing, though I could possibly graph both of these. And I want to come up with an answer. Now, in this case, both of the equations are set up in what we call the standard format. X, Y equal number. So we have two equations set up in standard format. It isn't as if we've been given X equal or Y equal in either of the equations. Though I could have possibly solved either for X or Y in either of the equations. As it stands, it's a perfect setup for this method that's called the elimination method. What do? I'm going to add these two equations down. Notice how everything lines up very nicely. X's, Y's equals numbers. We must have that if we're doing the elimination method. I add the two equations down. I'll have equals and equals. If I'm adding equal things to equal things, my end results are going to be equal. So I'm adding x plus 2x, that will give me 3x. Negative y plus y. Well, you know when you add a negative y and a positive y, you're getting 0 y's. In other words, the y's drop out. The y's are eliminated. That's why this is called the elimination method. And then we have 4 plus 8, which gives us 12. The advantage of adding the two equations is that at the end, we don't have two variables, we only have one variable. We only have x's, and of course I can solve this by dividing both sides by 3, and that gives me x equals to 4. I have now solved for one of the variables. I'm not finished because a system of equation requires me to get a solution with both the x and the y. It's not just alone the x, but we have to give the value for the y as well. So what I do is I go back to one of my original equations. It doesn't matter which one. Let's say I do the first equation. I'm going to do 4 minus y, because I don't know what the y is, equals 4. Now I'm going to solve this equation. I'll subtract 4 from both sides, which will give me negative y equaling 0. We know whenever we have a positive and negative of the same number, when we add them, we get 0. Of course, I now have to divide by negative 1, and 0 divided by anything is 0. So it turns out that my x is 4 and my y is 0. I can leave my answer this way, or I can write my answer as an ordered pair 4, 0. Remember, always put the x value first, the y value second. This is called the method of elimination because when we added our sometimes it's also called the addition method, because when we add the equations, we get rid of one of the variables, and that allows us to solve for the variable and then get the final answer. Is there any question about this? Okay, so let's do another problem. I'm going to do one more. Suppose I gave you this example. Four x plus 2y equals 32 is one equation, and x plus y equals -2 is our other equation. Again, we have a system of equations, and in this case, both equations are in the standard format, x, y equals number. Now, if I wanted to, I could take this bottom equation, either get the x alone or the y alone and use substitution, but I'm going to use the elimination method. Now, remember when I did the elimination method before, what I did is I just added down the two equations. But look what happens when I add these two equations. And if I add 4x plus x, I get 5x. 2y plus y is 3y. And 32 plus -2 is 30. I get another equation, but I haven't eliminated either of my unknowns. I haven't made the situation any simpler because this doesn't tell me 5x plus 3y equals 30, doesn't give me any other additional method of finding either the x or the y. So just adding the two equations is not the solution in this case. So let's analyze what made the other one work that we need to make this method work also. So arbitrarily, I pick one of the unknowns to get rid of. Anybody have a preference? Okay, if nobody has a preference, let's get rid of the x's. I decide I want to eliminate the x's. Now let's think about it. How would it work that I could eliminate the x's? The way it works is if the number in front of the x's are both the same number, but one has to be a positive number and one has to be a negative. In other words, if one is 5x, the other would have to be -5x. If one is -7x, the other one would have to be +7x. So I need to get the coefficients of the x. If that's the x is what I want to get rid of, I have to get their coefficients to be the same, but with opposite signs. In order to get them to be, so I do this as two separate steps. First, I work on getting them the same number. And I do that by simply multiplying each equation by the opposite coefficient. Now, there might be other ways of doing this. I'm giving you a method that for sure will always work. If you see another method that works, go right ahead and use it. I'm not saying it's the only method that can work. I'm giving you a method that for sure, though, will work. In other words, I'll multiply, and I'm just doing this with the numbers. I'm not even looking at the signs. I just take the numbers. The number in front of the bottom x is a 1, means I'll multiply the first equation by 1. The number in front of the x in the first equation is 4, means I'll multiply that equation by 4, the bottom equation by 4. And then I'll stick both of these. Remember, my objective is to get them to be both the same number, but one positive and one negative, so that when I add them, I'll get 0 as a sum. So now I look. I dealt with the numbers, now I'm dealing with the signs. They both are positive in this case. This is a positive 4, this is a positive x. I want to end up with one being positive and one being negative. So therefore, I'll have to multiply one of them. I'm going to have to use a negative with just one of them, not with both of them, but with one of them. So I picked the top one to be the one that I'm going to use the negative one. It doesn't make a difference. Look what happens now. If I multiply my first equation by -1, I will get -4x minus 2y equals -32. Be careful, you use to multiply everything on both sides of the equation by that number, in this case, -1. The second equation, we're multiplying everything by +4. So I will get 4x plus 4y equals -8. Be careful that you're, with your signs, make sure you're careful when you do your multiplications. Now let's see what happens when I add these equations. When I add the -4x and the +4x, they cancel out because it's going to be 0 x's, so there are no x's left. We've eliminated the x's. The -2y plus a 4y gives me 2y. The -32 plus a -8 gives me -40. And now I'll just divide both sides by 2, which will give me y equals -20. I have eliminated the x's and I've solved for my y. Now I go back to either one of the equations. I can take the first one and replace the y with -20. Let's say I take this equation. Then I will go 4x plus 2 times 20, -20 equals 32. So that'll give me 4x minus 40 equals 32. I'll add 40 to both sides. And I get 4x equals 72. Of course, now I can use my calculator and divide both sides by 4. And it ends up that x equals 18. So my final answer is x is 18, y is -20. So this is using the method of elimination. Again, keep in mind, focus on what you want to do. You want to make sure that the two, whatever variable you decide to get rid of, the coefficients will be the same number, but the opposite sign. Whatever you can do to accomplish that, that's what you have to do first, so that when you add them together, the two equations will be reduced to one equation. Yes, this is Amaya. You have a question?
Yeah, you say my name is Amia, but
Amaya,
so it's okay. If one of the equations is already negative, we don't have to make it negative, right?
That's exactly correct. If it turns out that one of them is already positive and one of them is negative, then the signs are correct. You don't want to fool around with those signs, you just work with the numbers. That's why I always like to do this as two separate thoughts. First, the numbers, I mean, it doesn't have to be, and the signs. Take them as two separate issues. Don't try to do it all in one set. Think, do I have to change the signs? No, leave the signs alone. Do I have to change the numbers? Yes, and multiply them by the opposite numbers. Okay, I'm gonna give you one to try on your own. Okay, let's see if I can, I think I saw one on a previous midterm that might be helpful. Okay, can I erase this now? Our first equation is going to be negative 7x minus 6y equals negative 21. And our second equation is 5x plus 3y equals 15. Okay, I'm going to give you some time to try this on your own.
Wait, Miss, nah, I'm sorry. Professor, can I ask you a question?
Sure.
So only when like the equation, I mean, like the format doesn't have a variable, that's when you have to like add the numbers. Like you see the last problem, the previous problem you used we just discussed. Like because you know like when doing the previous problem it was x plus y equals -2, and you said that we needed to add like the -1 because like we didn't have a
Right. If there's,
in this case we do have numbers though.
right, if there's, those numbers are called coefficients. When I use that term coefficients, the number in front of it, if there's no number, if it just says a plain X or a plain Y, it means it's understood to be a 1. Otherwise, it's just the number that's there. Here, we don't have to put a Y because the numbers are already there.
All right, thank you.
By the way, this method is also sometimes called the addition method. I just want you to know that it could be either called the elimination method because we're eliminating one of the unknowns, or it can be the addition method because we're adding the equations. That looks good. Day, that looks good. Yeah, a few people are coming up with the right answers. Good. Just give you another minute for the. Okay, I think we can work on this together now. Excellent, Adina. Okay, should we get rid of the X's or should we get rid of the Y's? Anybody have any feelings one way or the other? You want to get rid of the Y. Okay. If we're going to get rid of the Y's, and we're going to do it by my method, there might be a simpler method, but I want to use the method that I just taught. I look at the numbers. Remember, I'm just looking at the numbers. Worry about the signs in a minute. I'm going to multiply the top equation. Remember, it's the Y's I want to get rid of. So I'm going to multiply the top equation by 3. And the bottom equation I'll multiply by 6. And that will decide, do I have to use a negative sign? If you notice already, one of the Y's is negative and one of them is positive. And that's exactly what we want. We need one to turn out to be positive, one to be negative. I already have that situation. Let's not fool with that. Let's leave this, so we'll just use the numbers and we won't put any negative sign there. We only need to use a negative sign with one of them if either both are positive or both are negative. Once one is positive and one is negative, then we can just use multiply by positive numbers. So if we multiply the top equation by 3, we're going to get negative 21x minus 18y equals negative 63. And the numbers are getting a little bit bigger, then you can use your calculator. Remember, you're totally allowed to use a calculator. The bottom equation, 6 times 5x is 30x. 6 times 3y is 18y. Look at, that's what I'm looking for. A negative and a positive, the same number. A negative 18y, a positive 18y. That's going to be my elimination. 6 times 15 is 90. Okay, now we add. Negative 21x plus 30x is positive 9x. Negative 18y and positive 18y is eliminated. It's canceled out. Look at, we made the decision we wanted to eliminate the y's and we made it happen. What about here? Negative 63 and positive 90 gives me 27. Now I divide by 9 on both sides. And that will give me x equals 27 divided by 9, which is 3. I've now figured out what my x is. I want to go find out what my y is. So I take either one of the equations. I think I'm going to take this one because everything's positive. Usually easier to work with positive than negative, so it doesn't really make a difference. And I'm going to do 5. I'll go right over here. 5 times 3, because now I know what my x is, plus 3y equals 15. So this is going over here. 15 plus 3y equals 15. I'll subtract the 15 from both sides, which will give me 3y equaling 15 minus 15, which is 0. And when I divide by 3, 0 divided by 3, 0 divided by anything is 0. So it turns out my x is 3 and my y is 0. And that's what a bunch of people did send me that. And that is the correct answer. And notice, you wouldn't have liked to have done this by graphing or by substitution because the numbers are so difficult, but it was relatively easy to do using the elimination method. All right, I think we're going to stop right here. Let me just remind you that Tuesday's class again will be a recorded class. It will be a YouTube that you will find on CUNY Blackboard, just like the last one. It will be approximately 50 minutes to an hour, a review of chapters 1 and 2. You can then, after that, go on to Delta Math and find the test on chapters 1 and 2. That test has to be completed by the following Tuesday, which is, I think it's October 5th. Yes, October 5th. So you complete that test after you've watched the review. If you have not sent me the homework from Tuesday, September 21st class yet, make sure you do that in order to get credit for doing that homework. Even if the answers are wrong, that we're going to part of our review is going to be going over those examples. But you have to make sure to do those examples and send them in to me in order to get homework credit for that date. Does anybody have any questions they'd like to ask me? Don't forget that you can always send me email me questions. Again, I will not be here on Tuesday, but I certainly will be here next Thursday. And I will be glad to answer questions at that point. You can always email me questions, and you can always be in touch with me in some way. Ariana, you have a question?
When did you say that the homework from Tuesday's video was due?
It really should have been sent in already, the last Tuesday's homework, but as long as you do it by Tuesday, by the coming Tuesday, because then I'm going to be doing those class examples in class. Is that clear?
Yeah, and we just email it to you?
Just email me, right?
Okay.
Email me. A lot of people have already done it, but not everybody. Make sure to do it because you want to get credit for that. A good part of your mark includes your homework, which means doing the homework, even if you're getting the questions wrong, you get credit for doing the homework. All right?
I have a question.
Sure.
So wait, when we finish any of our Delta Math homeworks, we're supposed to email you to let you know?
Wait, most of your homeworks are on Delta Math, right?
Yeah.
I have access to your Delta Math. You don't have to.
Okay.
I
Okay,
see
good.
exactly. I can go to each problem that you did and see how many times you tried it. That's why it's such a good program. So but this one was not from Delta Math. This was questions that were in various parts of that lesson, and I wanted you to copy down those questions and send them in to me. Okay? And again, this time you will be there won't be any questions from that YouTube, but afterwards, it will be a review for your first test. So you want to watch that so that if you have any questions, again, and if you have any additional questions, then get in touch with Shireen. Have a nice week.
So, Professor.
Have a good weekend. Any other questions before it close? Okay, be well.